Welcome back. So there is this question that says a certain mass of hydrogen gas was collected over water at 16 degrees centigrade and 782 millimeter mercury. It has a volume of 40 centimeters cube. We are to calculate the volume of the dry gas at STP. But standard vapor pressure of water at 16 degrees centigrade is equal to 10 millimeter mercury. Now, the first step is to find the partial pressure, right? Because the actual pressure of the real gas is what we're going to be using. Now, if the total pressure given, first solution, if the total pressure, right, is equal to 782 millimeter mercury, right, then the pressure of water is equals to what? 10 millimeter mercury. But how about the pressure of the gas? The pressure of the gas is what we are going to be looking for, which is going to be what? Total pressure minus pressure of water. It's going to give you 782 minus 10. So it will give you 772 millimeter mercury. This very value now, since it is for the gas, is going to be our what? P1. Okay, so if that's P1, at standard temperature and pressure, our P2 we already know to be what? 760 millimeter mercury. Then temperature. Now we have what? The temperature here to be 16 degrees centigrade. So T1 is equal to 16 degrees centigrade, but we don't use degrees centigrade, right? So we have to convert it to Kelvin scale. So we have 16 plus 273. So this becomes Kelvin, and then we're going to be having 982 Kelvin, right? Okay, so based on general gas law, we have gotten P1, P2, T1, then how about V1? V1 is already given in the question to be what? 40 centimeters cube. Then what's left? P1, P2, T1. Now T2. So at standard temperature and pressure, T2 is always 273 what? Kelvin, right? Please don't forget that. Okay, so if these values are gotten, what we don't have now is V2, which is question mark. So using P1 V1 all over T1 is equals to P2 V2 all over T2. We're going to be making V2 the subject of the formula. So in that case, we'll be having V2 is equals to P1 V1 T2 all over P2 T1. So let's substitute our values into this now. P1 is gotten as 772 times V1 is 40, right? Times T2 is 273 standard temperature. P2 is 760 millimeter mercury, that's standard pressure, and T1 is gotten as 289. So let's multiply the numerators now and see what we're going to do. Let's multiply the numerator. We have 772 times 40 times 273. So we're going to be having 88430 divided by, let's multiply the numerator now. We have 760 divided by 289. 760 times 289. So we have 219640. So let's divide the numerator by the denominator now. So we'll be having 8430240 divided by 219,640. So we'll be having 38.38 centimeters cube. So our final volume can be taken as approximately 38 centimeters cube. Since we are working with two values, right? This one is 40, so this one is 38. So based on this calculation, the volume reduced. Okay, that brings us to the end of this calculation. If you have any question, make sure to drop them in the comment section of this video. Bye for now. I will see you in the next video.